All right, 5-3. We have not graphed with slope yet, but we have talked about slope, and we've been given graphs and found the slope. So let's try to work backwards through this and try to figure out exactly how we're going to graph it. So this says containing the point 3,2. What you need to know about graphing lines is you need two things to be able to graph a line. One, you need a starting point. Okay? Wherever that is, you need a place to start. You cannot just start randomly and be able to graph a line. So you need a starting point, and the second thing you need is the slope. Ooh. Two things: starting point, slope. So they gave us a point, 3,2, so I'm going to use that as my starting point. So write 3 up 2, plot the point. Ooh. Okay? Then your slope is -2. The other thing you need to understand is that your slope needs to be a fraction. So if they give you a whole number slope, we need to change it into a fraction. So my slope is a -2 over 1. And that is rise over run. So I'm going to graph from that starting point. My rise is a -2, which means I'm going to go down 2. And my run was a +1, which means I'm going to go right 1. So down 2, right 1. Then you're going to do the opposite to graph a second point, so that I'm going to go up 2, left 1, because I need to still have a negative slope. When I'm done, I can connect my points through my graph. Whoa. And then I have my line. Okay? My slope was negative, and my line is going down from left to right, which is what I wanted. Okay? So you need a starting point and a slope. Your slope has to be written as a fraction. And I'm going to ask you to graph a total of 3 points by the time we're done. Okay? So we're going to practice this a lot, but that's the basis. So we're going to talk about direct variation and how it relates to your slope. The direct variation equation is y equals kx. And that talks about your constant of variation, which sounds kind of like an oxymoron, right? Like variation means to change and a constant means to stay the same. So a constant of variation, but it's consistently changing the same way every time. That's what that means, okay? So your constant of variation, the way things are going to be written is you're going to have y equals, and then this is going to be a number, and then your variable x. The number in front of your x, so the number that's being multiplied by your x, is your constant of variation. That is how your x's are consistently changing by that factor of k. Okay? It's constant of variation. So it says identify the constant of variation in each equation. This is as easy as it sounds. The constant of variation in number 1 is 3. The constant of variation in number 2 is -2, which is the number in front of your x. The constant of variation in number 3 is 1/2. The constant of variation in number 4 is -5/4. So the goal of this is to show you that your constant of variation can be any kind of number. It can be a whole number, it can be a fraction, it can be positive, it can be negative. It's whatever number your x is being multiplied by, that's your constant of variation. Okay, that's it. So we're going to graph an equation that's in the same format as your constant of variation. So our constant of variation in this case is 3. Okay, we're going to graph a couple of these with an XY table. So I'm going to ask you to plug in, let's plug in -2, -1, 0, 1, and 2. That's what we're going to plug in for x. And we're going to find what y is. So since our constant of variation is 3, the consistency is that all of your x values are going to get multiplied by 3. So -2 times 3, -6. -1 times 3, -3. 0 times 3, 0. 1 times 3, 3. 2 times 3, 6. So these are our ordered pairs that we are going to graph. So -2, negative 6 is left 2, down 6. Okay? Negative 1, negative 3 is left 1, down 3. 0, 0, smack dab in the middle. 1, 3 is a positive 1, up 3. And 2, 6 is right 2, up 6. And it makes a line because if you're consistently changing the same way every time, it's going to make a line. Constant of variation equations make a line. Okay? It's positive, so different things to note. It's a positive line. And we're going to find the slope. So we can pick any 2 points on our line and count rise over run. So my rise, 1, 2, 3. Up is a positive number, and we're going right 1. 1 is also a positive number. So the slope, and right is also positive. So your slope is a positive 3 over a positive 1. If we notice, my constant of variation was also 3. So the constant of variation is 3 and my slope is 3. Okay, let's try another one. Here the constant of variation is negative 1/2. So I'm going to be consistently multiplying by negative 1/2. Since I'm in control and I know I'm going to be multiplying by half, remember multiplying by half and dividing by 2 is the same thing. So I'm going to pick even numbers to plug in for x just to make my life easier. So I'm going to do negative 4, negative 2, 0, 2, and 4 because that's going to make my life easier. So consistently, they're all going to be multiplied by negative 1/2. So negative 4 times negative 1/2 is 2. Negative 2 times negative 1/2 is 1. 0 times negative 1/2 is 0. 2 times negative 1/2 is negative 1. And then the 4 is negative 2. Okay. Graph them. Negative 4, 2. So left 4, up 2. Negative 2, 1. 0, 0, 2, negative 1, and 4, negative 2. Beautiful line. I can connect my points through my graph, and then I'm done. This is a negative line. You can tell by looking at it. It's going down from left to right, but let's find the slope specifically. So just pick 2 points. Doesn't matter. If I'm going to do rise, that's up 1, and then run, that's left 2. So that's a 1 over negative 2, or negative 1 over 2, or negative 1 over 2. Lots of different ways to write negative fractions, right? So you can have the negative on the top, the bottom, or on the outside. So either way, our slope is a negative 1/2. Well, our constant of variation was also a negative 1/2, if you remember up here. So the constant of variation is the number being multiplied by the x, and it is also ending up being my slope every single time. So the slope and the constant of variation are the same number. Also, something else I want you to notice. These two graphs only have 1 point in common. They both have 0, 0. If you think about it, it's because these equations don't have any addition or subtraction. If you think about when we had to find the patterns and we had to use x, y tables to write the equation, the only way to get from 0 to something is by adding or subtracting, and these equations, these constant of variation equations, don't have any addition or subtraction. It's only multiplication. So if we're only multiplying, there's not going to be any movement off of that 0. So 0, 0 is automatically going to be a point if there isn't any addition or subtraction. Okay, so your constant of variation and your slope are the same number. Same number. So, same thing, y equals kx, except now we also know that k is your slope. So it's your constant of variation, which is also your slope. All right, so these are the things we're going to do to graph today. First thing you're going to do is write your slope as a fraction. So if it's given to you as a whole number, you need to write it as a fraction. There is not going to be any addition or subtraction today, so you're going to have your starting point as 0, 0. So we said we needed two things. We needed the slope, and we needed a starting point. So there we go. We have everything we need. Okay? From 0, 0, I need you to graph two more points using your slope, one above and one below. Okay, so if your starting point is here, then you need to plot 1 point above and 1 point below using your slope. Then you connect them to make your line. All right, here's my equation. Whoa, I need a slope and I need a starting point. My slope is my constant of variation, which is 4. It's a whole number, so to write it as a fraction, I put it over 1. It's positive. 4 over 1 is a positive number, so I need to make a note to myself that my line is going to be going up from left to right, okay? All right, and then my starting point, since there is no addition or subtraction, is 0, 0. So this is rise over run. Let's practice it. 0, 0 is our starting point. So here, my rise was a positive 4. 1, 2, 3, 4. My run was a positive 1. Right 1. Let's do that in a different color. Okay. Then, I'm going to go back to my starting point, and I'm going to do it again. But I'm going to move in opposite directions. So I'm going to move down 4 and left 1. So down 4, left 1. So my slope is still 4 over 1. I just used 2 negative movements instead of 2 positive movements. So then that way I have points on both sides of my starting point. Okay? And there's your line, and you're done. Easy peasy. All right, here, our slope is our constant of variation, which is a negative 1 over 3. It's already a fraction. Just notice that this time your slope is negative, so your line's going to be going down from left to right. There's still no addition or subtraction, so my starting point is 0, 0. So 0, 0 in the middle. Boop. Negative 1 over 3, so down 1, right 3. The opposite of down 1, right 3 is up 1, left 3. And there are my 3 points, and I can connect them through my graph. It is going down from left to right, which is a negative slope, which is what I wanted, so I'm good to go. Last one. Slope. There isn't a number in front of the x, which means it's a 1. So your slope is 1 over 1. Your starting point is 0, 0. A positive slope means your line should be going up from left to right when you are done. So plot it. 0, 0. 1 over 1 just makes you go up 1, right 1. You can do as many as you want. You can keep going up 1, right 1. The opposite of that is down 1, left 1. So then you have all these points. You only need 3, but if you want to do more, you always can. And then you connect them. And it's going up from left to right, which is a positive slope, which is what I wanted. All done. 5-3 worksheet.